In this video, we are going to solve exercise 1.3 question number 1. The question is, prove that root 5 is irrational. So again, we will be using over here method of contradiction. Let's start with the solution. So first of all, we will write down let root 5 be a rational number. Root 5 be a rational number. So definitely we can write down root 5 in the form of p by q, and we can write down root 5 equals to p upon q, where q is not equals to 0. Also, the conditions are p and q are coprimes, which means the highest common factor, or we can say the HCF of P and Q is equals to 1. This is what we have assumed. Now, definitely if root 5 can be written in the form of P by Q, on cross multiplying, we can multiply Q with root 5. We'll get root 5Q equals to P. Now, name it as equation 1. Square on both the sides. So, we will square on squaring both sides, we will get root 5q whole square, that will be equals to 5q square, and p whole square, that will give us p square. So from this we can write down q square is equals to p square upon 5. P square upon 5, which implies what? We can say that 5 divides p square. Now if 5 divides p square, 5 is a prime number, if it divides p square, then definitely 5 will divide p also. So we can write down 5 divides p also. Right? Now if this happens, we can assume what? Let's say p by 5 is some number c. Let p by 5, on dividing p with 5, we are going to get some number. Let's say that is c. So from this we can write down on cross multiplying p is equals to 5c. Right? Mark it as your equation 2. P equals to 5c. Mark it as your equation 2. Now this value of p that you have got, you have to substitute it in equation 1 from equation 2. So we'll write down, put value of p from equation 2 in equation 1. On doing this, what are we going to get? We will get root 5q is equals to, in place of p, we will write down 5c. Now again we got root 5q equals to 5c. So we will square on both the sides. If you will square on both the sides, it will give us 5q square equals to 25c square. 5c whole square will be 25c square. Now on simplifying this further, what are we going to obtain? We will get q square is equals to 25c square upon 5, which can be written as q square is equals to 5c square. Or we can write down from here q square upon 5 is equals to c square, which implies 5 divides q square. Now if 5 divides q square, from the theorem we can say that 5 will divide q also. 5 divides q also. Right? Now from this, what did we observe? That let's say if we are dividing q with 5, we are going to get a number, right? A question. Let's say that number is equals to d. So we have assumed let q by 5 is equals to d. And from this we can write down q is equals to 5d. Right? Q equals to 5d. But from the equation 2, we got P equals to, from equation 2 we got P equals to 5C, and here we are getting Q equals to 5D. Since Q is equals to 5D and P is equals to 5C, what can we say? 5 is a common factor in both of them, P and Q. But our assumption said that P and Q are co-primes, which means the HCF, the highest common factor of P and Q, should be 1, right? So we will write down, but HCF of P and Q was 1 according to our assumption. According to our assumption. So according to our assumption, HCF of P and Q was 1, right? But as a result, we got that HCF of P and Q came out to be 5. There is a common factor between P and Q, that is 5. So this contradiction has arisen due to our wrong assumption. Due to our wrong assumption. Our assumption was that root 5 is rational. Right? So this contradiction has arisen due to our wrong assumption that root 5 is rational, which basically means that it implies root 5 is irrational. So this is what method of contradiction means. We start with a wrong assumption and as a result we get the result to be wrong, right? So we say that our conclusion is wrong because of our wrong assumption initially. So this is called as method of contradiction. Here we got HCF of P and Q on solving equals to 5. But initially we assumed that HCF of P and Q should be equals to 1 because root 5 can be written in the form of P by Q where P and Q are co-primes, right? The HCF of P and Q should be equals to 1. But as a result on solving we got HCF of P and Q equals to 5. So there is a contradiction in both of them. It has arisen due to our wrong assumption that root 5 is rational. So we will conclude that root 5 is irrational.